Alrighty, good morning. We are going to get started on notes for chapter 6 and 6.5. We are going to learn how to graph inequalities. It should be something that you guys recognized from last year and pick up on real quick. So for the reminders, I'm going to let you guys look that up or fill it out. You should know what all of those are. But once you do that, after you pause and do that, and we're going to get started on is this a solution right away. So for that section, we are given a coordinate point, and we need to plug that coordinate point in for x and y. So my x value goes in for x, and my y value goes in for y. So we have 2 is greater than 2 minus 3. So when I simplify that, I get 2 is greater than 2 minus 3 is negative 1. Is that true? Is 2 greater than negative 1? Yes. So then that means that yes, this is a solution. Solution, remember, means that it makes the statement true. Okay? Is the statement that's in the box true? Yes or no? If it isn't, it's not a solution. If it is a solution. So I'm going to give you about 30 seconds to look at example number 2 and fill in that point and evaluate if that is a solution or not. Is this true or is this not? Well, when we think about it and we look at the number line, we know that negative 8 is not greater than negative 6. So then this is not true, which means that no, this is not a solution. That is as simple as your answer can be. So now let's take a look and go to our graphing and inequality section. You guys are going to be pros at this. You'll be great. So I wrote some steps up here there. Your steps are number 1 to graph the boundary line, number 2 to test the point 0, 0, and step 3 is to shade. I'm going to walk you through that with the first one. So example number 3 says that y is greater than x minus 2. So we are going to graph the line that is associated with this, which is y equals x minus 2. We should know how to do this, no problem. So when I look here, I see that I have a y-intercept of negative 2. So I'm going to go down to negative 2 and put a point. And then I'm going to go use my rise over my run, which is 1. So I'm going to go up 1 over 1 for all of these. See how I'm making dots all the way. You don't have to make as many as me, as long as you're getting the general gist of things. So I have my line graphed, but I'm not done. We need to keep in mind that when we have this sign right here, that means that it is greater than. Okay? It's not greater than or equal to, it's just greater than. That means that we are going to use a dotted line to connect, or dashed line to connect our dots. This is super important, and if you use a filled in line instead of a dashed line, you won't get it all correct. So be really careful. We'll also review that in a second. So now step 2 says to test a point 0, 0. That means I need to take the point 0, 0 and plug it into my equation to see if it's true. So I'm going to take 0, 0 and I'm going to plug it in here. 0 in for y and 0 in for x. So I have 0 minus 2. 0 is greater than negative 2. Is this true? Yes, that is true. That is a solution. That means I'm going to shade on the side of the graph where 0, 0 is. So 0, 0 is over here. That means I need to shade this side of the graph. So I'm simply going to shade right here. There we go. I'm going to go through example number 4 with you, and then I'm going to let you try a couple on your own. So this one, first thing we're going to do is graph our line. Our line is x equals negative 1. We should know how to do these really well. They were on our last couple tests. So x equals negative 1, means that I'm going to go to -1 over here on my x-axis, and it's going to be a vertical line. Now, you can draw the dots in there, you don't have to, but the thing we need to be careful of is that this is a greater than sign, meaning that I need to draw a dashed line in, not a solid line. Be careful of that one. And now I need to test the point 0, 0. So I'm going to plug 0, 0 in, and I get 0, plugged in for x, is greater than -1. Is that true? Yes. That means I'm going to plot the point 0, 0 right on my line, and I'm going to shade that side of my graph. And it doesn't have to be perfect as long as I can see the general gist of things. So now I'm going to give you guys about 2.5 minutes to graph example number 5 and example number 6 here down on the bottom. You should be able to do that real quick, and then we'll go through them. Alrighty, so here is example number 5. Things that you should notice. That my line is solid. Notice that its y is greater than or equal to. With the equal to part on there, you need to make sure that you know that it is a solid line and not a dashed line. Other thing you should notice is that when I plugged in my point 0, 0, it tells me that 0 is greater than or equal to 4. That is not a solution. When it is not a solution, you do not highlight on that side. You highlight on the other side of the line. So you'll notice that I highlighted above, not below the line. Now, for example number 6, I have a dashed line, a vertical dashed line at -3, and then I plugged in my point and I see that 0, 0 is a solution, so I highlighted on the side of the line that is a solution. So it is on the right-hand side. Now let's take a look at the important part above where it says dashed lines are used when we have greater than or less than symbols. And then solid lines are used when we have greater than or equal to and less than or equal to symbols. Make sure you understand that and have it done well. Alrighty, so now we need to take a look at example number 7. Example number 7, we have a word problem. It says an interior decorator is going to remodel a living room, dining room area. The floor is going to be redone with part carpet and part hardwood. The hardwood area is 16 feet squared and the carpet area is 38 feet squared. The owners can only afford to spend $1,200 on flooring, right? An inequality and graph the possible solutions for the situation. So we are only going to write one equation for this. You guys should be pros. You should see that we have two little pieces of information and a big one. We have 16 feet and we have 38 feet squared and a total of $1,200. So we are going to use standard form. This will give us an equation of 16x plus 38y equals 1,200. This equation we will now graph. So if you need to rearrange this into standard form, into slope-intercept form to graph it, do it, but I'm going to let you guys graph it and see if your equation matches mine. One other thing that we need to make sure we have is an inequality symbol, not an equal sign, right? So because they cannot spend more than $1,200, we need to have a greater than less than or equal to symbol. So the 16x plus 38y cannot be greater than $1,200. Graph this equation. I'm going to give you a couple minutes to do that. Okay, you should see a couple things as you look at my solution. You should see that I have a solid line because it's a less than or equal to symbol, and then you should also see that I shaded underneath the graph. This shows all of the possible options that I can pay for my hardwood and my carpet and still be under $1,200. Let me know if you have any questions about that. Now is the time to ask, but other than that, you should have a good chunk of notes on this. And when you're done, you can do the practice for 6.5. Adios.